Integrals of some particular functions. See page numbers 307 and 308.
6 formulae are given. Integral dx divided by x square minus a square is equal to 1 by 2a log of absolute value of x minus a divided by x plus a and plus c. The second formula, integral dx divided by a square minus x square. Only sign difference is there in these two. So we can write minus of the previous answer or you may take that minus sign as the power, so it becomes the reciprocal, x plus a in the numerator and x minus a in the denominator, and plus c. Because we have absolute value function, this can also be written as a plus x divided by a minus x. Does not matter because of the absolute value sign. Then third formula, integral dx divided by x square plus a square, 1 by a tan inverse of x by a plus c. Fourth formula, integral dx by root of x square minus a square is equal to log of x plus root of x square minus a square and plus c. Number 5, integral dx by root of a square minus x square is sine inverse of x by a plus c. Sixth formula, integral dx by root of x square plus a square is log of absolute value of x plus root of x square plus a square plus c. Memorize these 6 formulae and write them in the formula notebook. I will just show you the derivations of these formulae, but derivations are not important, you need not learn. But if I show you the derivation, it will be easier for you to memorize them. 1 by x square minus a square can be factorized as x minus a into x plus a, and I can separate this into two fractions, 1 by x minus a minus 1 by x plus a. Actually, we will be learning this in partial fraction method in exercise 7.5. So if I take LCM, the numerator will be 2a. So to cancel that 2a, I am writing 1 by 2a. Now let us write the integral of this. So it becomes 1 by 2a. Integral of the first term is log of absolute value of x minus a. Integral of the second term is log of absolute value of x plus a and plus c. And this can be combined as log of x minus a divided by x plus a. After doing exercise 7.5, this method will be easy for you to understand. Now the next formula is, I told you only sign difference is there. So we can write minus of this. Or you may take minus sign as the power. Therefore it becomes the reciprocal. X plus a divided by x minus a it becomes. Or we may write this as absolute value sign is there. We may write it as a plus x divided by a minus x also. Now see the third formula. Dx divided by x square plus a square. We will use the substitution a tan theta or a cot theta. A tan theta will be better. Let us differentiate a times secant square theta d theta. Let us substitute. The numerator becomes a secant square theta d theta divided by a square tan square theta plus a square. We can take a square out from the denominator and we get 1 plus tan square. 1 plus tan square becomes secant square. It becomes 1 by a, which is a constant, 1 d theta. An integral of 1 is theta, and we have to substitute for theta from here. So x by a is tan theta. So theta will be tan inverse of x by a. Therefore, the answer is 1 by a tan inverse of x by a and plus c. This tan inverse formula has 1 by a outside because we have a in the numerator and a square in the denominator. So it comes out as 1 by a. Then fourth formula, we have dx divided by root of x square minus a square. Let us substitute x as a secant theta so that identity can be used. Differentiate dx is a secant theta into tan theta d theta. Therefore, the integral becomes a secant theta tan theta d theta divided by x square is a square secant square theta minus a square. Here we have root sign in the denominator. If you take a square out, it becomes a, whereas in the previous case there is no root sign. So a square comes out. That's why the answer has 1 by a outside. Now root of secant square minus 1 is tan square theta, identity. So root of tan square and tan will get cancelled. Integral of secant theta is log of secant theta plus tan theta. Log of secant theta is x by a from this substitution. And tan is, we know that tan theta is square root of secant square theta minus 1, identity. Therefore, it becomes root of x square by a square minus 1. We'll take LCM. So it becomes x plus root of x square minus a square divided by a. Now log a by b can be written as log a minus log b. So it becomes minus log a plus c. A is a constant, log a is also a constant. So we can write this as some other constant c1. Or we will take c1 here and finally these two together we will write it as c. That's how we get this formula. Now fifth formula, integral of dx by root of a square minus x square dx. We have 1 minus sine square identity or 1 minus cos square identity. So we can substitute x as a sine theta or cos theta. I am substituting a sine theta. Let us differentiate. Dx is a cos theta d theta. A cos theta divided by root of a square minus a square sine square theta. This is equal to, take a square out. Outside the root it becomes a. 1 minus sine square theta is cos square theta. A could be cancelled. Cos theta also gets cancelled. It becomes 1 d theta, which is theta. So theta is sine inverse of x by a from here. There is no 1 by a outside for this formula because root sign is there. If you take a square out, it becomes a, that a and numerator a are getting cancelled. Whereas in the third formula, we don't have square root. A in the numerator, a square in the denominator we have, that's why 1 by a is there outside. Similarly, we can prove the sixth one by substituting a tan theta. It is similar to the fourth one. So derivations are not important. I derived them so that it will be easy for you to memorize these formulae.
See the third formula, integral 1 by x square plus a square dx is 1 by a tan inverse of x by a plus c or minus 1 by a cot inverse of x by a plus c. Similarly, the fifth one, integral 1 by root of a square minus x square dx is equal to sine inverse of x by a plus c or minus cos inverse of x by a plus c.
Now using these 6 formulae, let us do the first 9 questions of exercise 7.4. First question, integral 3x square divided by x raised to 6 plus 1 dx. We have x power 6 in the denominator and numerator has x squared. We know that differential of x cube gives us x squared term. So let us substitute x cube as t. Differentiate both sides. So when the question is given, look at the function and check differential of which function gives you the other function which is given in the question. So the numerator becomes dt. The denominator x power 6 can be written as x cubed the whole square, which becomes t squared. Now we can apply that third formula, which is tan inverse of t. 1 by a is 1 here. And substitute for t. T is x cube. So the answer is tan inverse of x cube plus c. Now the second question. 1 divided by root of 1 plus 4x square dx. We can take 4 out. It becomes 2 root of 1 by 4 plus x square. So half into integral. 1 by 4 can be written as half square plus x square dx. Now use 1 by root of a square plus x square formula. So half into log of absolute value of x plus root of x square plus 1 by 4 and plus c. Or you can do it directly without taking 4 also you can do. Root of 4x square can be written as 2x the whole square and use the formula. So it becomes log of x here is 2x plus it's a linear function of x, so we can use the formula root of 1 plus 2x the whole square, which can be written as 4x square plus c. But don't forget to divide by the coefficient of x. So we may forget to divide by the coefficient of x. So that's why it is a better practice to take out the coefficient of x square and then do the integration. Question 3. Integral 1 divided by root of 2 minus x the whole square plus 1 dx. So this is a linear function of x. So we can apply this formula root of a square plus x square formula, which is log of absolute value of x plus root of a square plus x square. Log of, in this case, x is 2 minus x plus root of 2 minus x the whole square plus 1 and
plus c.
And we have to divide by the coefficient of x here. The coefficient of x is minus 1. So divide by the minus sign. Therefore, the term becomes negative. This is the coefficient of x. Question number 4. Integral 1 divided by root of 9 minus 25x square. Let us do it directly without taking 25 out. But you should not forget to divide by the coefficient of x. That is very important. Now 9 can be written as 3 square and 25x square can be written as 5x the whole square dx. We have to use 1 by root of a square minus x square formula, which is sine inverse of x by a. Therefore, the answer is sine inverse of x here is 5x and a is 3. And don't forget to divide by the coefficient of x. 5x is a linear function of x, therefore the formula is applicable. If you have some other function other than linear function of x, if you have quadratic or cubic or trigonometric function or exponential function or logarithmic function, the formula is not applicable. And plus c. Question 5. Integral 3x divided by 1 plus 2x power 4 dx.
If you notice, in all those 6 formulae, the numerator is 1 and the denominator has constant term and x squared term. In this question, we have x power 4 in the denominator and x term in the numerator. We cannot apply the formula.
And we know that differential of x square term gives x term. So we will substitute x square as t, differentiate both sides. X dx is dt over 2. Let us substitute. X dx is dt divided by 2 and the denominator is t square. 3 by 2 is a constant. Dt by, I can write 2t square as root 2t the whole square, or let us take 2 out. So it becomes half plus t square, that is keeping the coefficient of t square as 1. Now this is 3 by 4 dt divided by 1 by root 2 the whole square and t square. We have to apply integral dx by a square plus x square formula, which is 1 by a tan inverse of x by a. Three by 4. A here is 1 by root 2. Tan inverse of x by a is 1 by root 2. I can cancel root 2 and 2, so it becomes 2 root 2 in the denominator, and tan inverse of root 2t, and substitute for t. T is x square plus c. Question number 6. Integral x square divided by 1 minus x power 6 dx. And we know that differential of x cube term gives us x square term. Therefore, let us substitute x cube as t. Differentiate both sides with respect to x. 3x square dx is dt. Therefore, x square dx becomes dt divided by 3. dt divided by 3. And the denominator becomes t square. X power 6 can be written as x cube the whole square, which becomes t square. Now let us use 1 by a square minus x square formula, which is 1 by 2a log of absolute value of a plus x divided by a minus x plus c. Let us use this formula. I have told you we may write this as absolute value of x plus a divided by x minus a. Because of absolute value sign, it does not matter. Therefore, the answer is 1 by 3 times 1 by 2a. A is 1. Log of 1 plus t divided by 1 minus t and plus c. 1 by 6 log of, substitute for t. T is x cube. This is the answer. These questions are easy because direct application of the formulae. Question number 7. X minus 1 divided by root of x square minus 1 dx. To apply these formulae, the numerator should be a constant or 1. But here we have x term and denominator already has x square term. So we will separate the terms as x divided by root of x square minus 1 dx and minus 1 divided by root of x square minus 1 dx. Here directly we can use the formula. Here we need substitution. Let us substitute x square as t or x square minus 1 as t, or we may take root of x square minus 1 as t. Square both sides to remove the root sign. Differentiate both sides. The substitution is only for the first integral. So t dt divided by the denominator is t. We are not using substitution for the second integral. We have direct formula for this. An integral of 1 is t, and this formula is log of absolute value of x plus root of x square minus 1 plus c, and substitute for t. T is root of x square minus 1. You have to be thorough with these formulae. Question number 8. Integral x square divided by root of x raised to 6 plus a raised to 6 dx. We'll substitute x cube as t because differential of x cube term gives x square term, x square dx. Differentiate both sides. Therefore, x square dx is dt divided by 3. The numerator x square dx becomes dt divided by 3, and the denominator root of x power 6 can be written as x cube the whole square, and x cube is t, so it becomes t square. A power 6 can be written as a cube the whole square, and we will use integral 1 by root of x square plus a square dx formula, which is log of absolute value of x plus root of x square plus a square plus c. One by 3 times log of x here is t plus root of t square plus a raised to 6 plus c. Here we have a cube the whole square. A is a constant, so formula can be applied. But if you have t cube the whole square or x cube the whole square, these formula cannot be used. So the variable term should be t square or x square. You should not have other powers. Now let us substitute for t. 1 by 3 times log of absolute value of t is x cube plus root of t square will become x raised to 6 plus a raised to 6 and plus c. Question number 9. Integral of secant square x divided by root of tan square x plus 4. Let us substitute tan x as t. Differentiate both sides. Secant square x dx is dt. The numerator becomes dt. The denominator becomes root of t square plus 2 square. We will use 1 by root of x square plus a square formula, which is log of absolute value of x plus root of x square plus a square. While doing the sums, referring the formulae and doing is not going to help. Memorize and be thorough with all these formulae. Equal to log of t plus root of t square plus 2 square, which is 4, plus c. Let us substitute for t. Now we have to learn the next method to continue the exercise. So the next method is
integral 1 divided by ax square plus bx plus c dx, or integral 1 divided by root of ax square plus bx plus c dx. The method is take a out from the denominator and complete the squares. After completing the squares, we use one of those 6 formulae. But remember, negative sign should not be taken from the root sign. You cannot remove negative sign from the root sign. Only positive numbers can be taken out. Negative numbers cannot be taken outside the root sign. Write down this in the formula notebook.
While doing the questions, I'll explain the completion of squares method. Let us continue exercise 7.4. Question number 10. Integral 1 divided by root of x square plus 2x plus 2 dx. We have x square as well as x term. So we need to complete the squares. A square term is x square. So a will be x. 2ab term is positive. So plus. We have to find b. This is our 2ab term. So divide the coefficient of x by 2 because 2ab. So divide by 2. It becomes x. And then divide by this a term also. It becomes 1. Or if the coefficient of x square is 1, say, then just divide the coefficient of x by 2 and write. If I expand, I get x square plus 2x plus 1. I don't want this b square term, so minus 1 should be written and copy this plus 2. That's how we complete the squares. So you need practice. It is easy. Just if you practice a few questions by yourself, you will be able to complete the squares very easily. So x plus 1 the whole square minus 1 plus 2 dx. Let me explain this completion of squares again. We are going to complete the squares for this expression. I am going to complete the square using the first two terms. A square term is x square, so a will be x. 2ab term is positive, so plus sign. If 2ab term is negative, you will have minus sign. Then you have to divide the coefficient of x by 2 because 2ab in the formula we multiply by 2, no? So divide by 2. And you have to divide by the coefficient of x also. But here the coefficient of x is 1. That's it. B term is 1. Complete the squares. We don't want b square term. So minus 1 and write this plus 2.
Or you may add 1 and subtract 1. and write x square plus 2x plus 1 as x plus 1 the whole square, and that minus 1 plus 2 will become plus 1.
Integral 1 divided by root of x square plus a square formula. It is log of absolute value of x plus root of x square plus a square plus c. Therefore, the answer is log of absolute value of x here is x plus 1. See this? Plus root of x square plus a square is this expression. But if I open the brackets and simplify, I get the original expression x square plus 2x plus 2 and plus c. This is the answer. Question 11. Integral 1 divided by 9x square plus 6x plus 5. We have two methods. We may take 9 out and then complete the squares, or keeping 9 also we can complete the squares. A square term is 9x square, so a will be 3x, and 2ab term is positive, so plus. I told you to divide this by 2 first. The coefficient should be divided by 2, and you have to divide by this coefficient also. So 2 3s are 6, which becomes 1. B term is 1. The whole square. Let us expand and check. 3x plus 1 the whole square is 9x square plus 6x plus 1. So I have 9x square plus 6x. To cancel this, I have to subtract that b square term, and plus 5 is there in the expression. To do this integration chapter, you need lot of practice. This is equal to integral 1 divided by 3x plus 1 the whole square. This is plus 4, which can be written as 2 square. Now we will use integral 1 divided by x square plus a square formula, which is 1 by a tan inverse of x by a plus c. This is equal to 1 by a is 2, tan inverse of x is 3x plus 1 divided by a is 2 and into 3. What is this 3 for? The coefficient of x. This is a linear function of x. So the formula is applicable, but don't forget to divide by the coefficient of x. Therefore, the answer is 1 by 6 times tan inverse of 3x plus 1 by 2 plus c. Otherwise, it is a better practice to take out the constant 9, the coefficient of x square, out and then complete the squares. But you will have fractions. Final answer will be the same. Question 12. Integral 1 divided by root of 7 minus 6x minus x square dx. We will take out the negative sign, but remember we can take out the negative sign outside the expression but not outside the root sign. It makes the number complex. So don't remove the negative sign outside the square root. Keep it inside the square root. Just outside the expression I am taking it out. Plus 6x. Therefore it becomes minus of x square plus 6x minus 7 dx. We'll complete the squares. Integral 1 divided by root of minus of, use two types of brackets, one for completion of squares, one for this minus sign. x square plus 6x minus 7. A square term is x square, so a will be x. 2ab term is positive plus sign. Divide the coefficient of x by 2, which is 3. And you have to divide by this coefficient also. So 6 divided by 2 and by this x coefficient, which is 1, which is 3. Complete the squares. Subtract b square term and this minus 7. Therefore, minus of x plus 3 the whole square minus 9 minus 7 is minus 16, which can be written as minus 4 square times dx. Distribute the negative sign. So 1 divided by root of 4 square minus x plus 3 the whole square. We will use the formula integral 1 by root of a square minus x square dx, which is sine inverse of x by a plus c. Therefore, the answer is sine inverse of x, here is x plus 3, divided by a is 4, and plus